work on square roots on 9.2, and this time we're going to talk about the concept of simplifying the square roots. So first of all, we're going to compare a pair of products. So the first pair of products is going to be the square root of 4 times the square root of 16. So if we want to simplify that, the square root of 4 is 2, the square root of 16 is 4, and 2 times 4 is 8. Now we're going to show this in a different form here, and if I did instead, I did the square root of 4 times 16. So the first thing I'm going to do there is I'm going to simplify what's under the radical sign, and I'm going to change that to, that's the same as what is the square root of 64. And the square root of 64 is also 8. 8 times 8 equals 64. So we can use that as it's called the product property of square roots, and it means that if you have A and B separate, so this would be A, 4, and 16 would be B. So having the square root of those separately, if neither one of those numbers is 0, then and then putting them together as a product is the same as having them together as a product under the radical sign, and then putting them together as so adding or putting them together as a product and then finding that square root. And of course that's said better and without stumbling in the print here on the screen. Now let's go ahead and put some of these in action. So if I want to find the square root of 180, and that's not one that I know by heart. So I'm going to break 80 into some numbers that I know are perfect squares. And so I'm going to say 80 would also be the same as, let's try doing it as 36 times 5. 36 times 5 equals 180. And now I can split those apart, and I can find the square root of 36, and I can find the square root of 5. The square root of 36 is my perfect square that is thinking of 6. And then I can't simplify square root of 5, so I simply write it like this. The answer there would be 6 square root of 5. That's the simplest form that could be. All right. The next one we're going to try to do is going to have a variable in it. So we're going to start out with the square root of 24, and it's going to be s squared as the rest of our term there. So again, I'm going to kind of factor that out there. I'm going to change it to 4, and because I know 4 is a perfect square, and 4 goes into 24 6 times, so 4 times 6, and then I'm going to go ahead and I'm going to put in my variable, s squared. So now I'm going to look at those as separate terms, square root of 4 times the square root of 6 times the square root of s squared. So the square root of 4 is that perfect one, 2. The square root of 6 cannot get any simpler. And then the square root of s squared is going, whoops, sorry. The square root of s squared would simply be s. Because square root means, how do you get there? S times s. So s times s, the simplest form there would be s. Now I have different kinds of terms. I have 2 of them that have come out of the radical sign. And so when I write that final answer, I'm going to put those together. So 2s, and then I will go ahead and put the radical to the square root, or 2s square root of 6. That's going to be in its simplest form. So again, taking it apart with a perfect square, if we know a perfect square that goes into it, and then simplifying that till we have terms that are in their simplest form, and we have the terms that are still underneath the radical sign. Moving on, we're going to go to division now, quotients. So it says there, notice that, and I'm going to give you another expression here, 100/4, or that would be 100 over 4, or 100 divided by 4. I'm going to simplify that first. 100 divided by 4 is actually 25. So now we have the square root of 25, and the square root of 25 is equal to 5. So that's the property when we are using quotients. So this results This result suggests that the quotient property of square roots, which you can also use to simplify radical expressions. So let's go ahead and try doing one of these. We will go ahead and we will try the square root of 13 over 36. Now 13 over 36 cannot be simplified, cannot be divided out into something simpler. So we're going to go ahead and apply it that it would be the square root of 13 and the square root of 6. Now, the square root of 13 is going to stay the square root of 13. And, oops, I missed my 36. There's where my problem was. Square root of 13 is going to stay the same, and square root of 36 is going to simplify to 6. This here is in its simplest form. Let's go back up to our first one that we did, 100 divided by 4, and this time let's work it out a little bit different. Instead of simplifying right away to the whole number, let's go ahead and show this one that it proves the one above it. So the square root of 100 and the square root of 4. The square root of 100 would be 10, and the square root of 4 would be 2, and 10 divided by 2 would still get us to the same answer when we simplify. So you have some different approaches. If you can simplify, simplify to that whole number, and then you can find the square root. If you don't see that right away, take each one of them and change it into radical forms and see if you can find either both or one of their square roots. All right. Let's do, looks like I have just some room for a couple other ones where we're going to do some checkpoint here. I used the room okay on the last one, so we don't need to do more of example 3. So this is just going to be randomly all the things that we just did. So if we're going to do the square root of just a number, 63. First thing we're going to do is we're going to see if we can break that up into anything that would have any factors that would have square root, perfect square root. So I'm going to do, how about the square of 9, square root of 9 times the square root of 7. My 9 can be simplified to 3, and the square root of 7 has to stay the same. So I have 3 to the square root of 7. Let's try one with a variable in it was our next step. So we have 54 t squared. I'm going to take that apart into simpler terms. So I'm going to do, let's try 9 times 6. 9 times 6 will still give me my 54, and then my variable term. And let's see if any of these are perfect square roots. The square root of 9 is 3. Square root of 6, we can't get that any smaller. Let's go to the next simplified one. Square root of t squared could just be t. And then I'll go ahead and leave my radical symbol in that one. And then the last one we did was a division one. We'll try one more of those. 32 divided by n squared. This time I'm putting a variable in there. We did not do an example like that. So I can't do any simplifying in the division yet. So let's go ahead and just do the numerator and the denominator. Let's change our 32 to the square root of 8 times the square root of 4. 8 times 4 gives me my 32. And that's going to be over the square root of n squared. 8 cannot be simplified to a perfect one, but the square root of 4 can. So I have 2 to the square root of 8. And I have the square root of n squared would be n. However, I think I can go a little bit more there. Let's do 2 times the square root of 4 times the square root of 2. And we've already simplified that to n. The square root of 4 now is going to be 2. So I have 2 times 2 times the square root of 2 over n. And I ran out of room, so I'm going to go above it here a minute. And so now I can simplify my two perfect squares to 4 square root of 2 over n. Okay, so even if you don't find the best place to start, we start with 8 times 4 that time, you can keep simplifying. Okay, if we would have done 16 times 4, or 16 times 2, we would have been able to jump right to the 16 square root is 4, and then the square root of 2 there. We'll do one last one, and this one's going to be a real life one. This one's going to be a story problem where after a car accident, a police officer can measure the length, and he views in feet, of a car's skid marks. The expression, and when he does that, the expression will give the car's speed in miles per hour at the time that the brakes were applied. So the expression that we're going to use for this one is going to be 27, and that's 27 times L, meaning the length. So the square root of 27 times L. So it says, write the expression in simplest form, and we need to go ahead and simplify the expression that they gave us as the formula. So the expression 27 times length. The square root of 27. 27 I know I can get to by 9 times 3. And then I also have to keep my variable in there. So the square root L. 9 can be simplified. Square root of 9, the perfect square root is 3. And then we also have the parts we can't simplify, which would be the square root of 3 and the square root of the length. That's going to be my formula. So now, if I have an actual accident, it says the skid marks are 120 feet long. So use the simplified expression to approximate, there's that word again, approximate the car's speed when the brakes were applied. So I'm going to take my formula, 3, my new simplified one, times the square root 3 times length. So let's go ahead and put in our information. So when we put in our information, we would have 3 times the square root 3 times the length was 125. When I do that, I can go ahead and multiply that out, and I have 3 times the square root of 375. And when I do that, I can find that the square root of 375, one second, sorry, pause it, see what's going on. 375 does not have the perfect square, so I'll go ahead and use my calculator. And when I get to 375 square root, it's about 19. And then if I multiply that by the 3 right here, the 3 times 19, I would get it's approximately 58. So that would be 58 miles per hour. And again, when we're using real life, we have some that will not turn out to be perfect squares. So we'll go ahead and just use what we learned in 9.1 to get a close approximation. That does it for lesson 9.